Welcome everybody to today's webinar. So just to give a bit of background, this event is actually the first as part of a new project that we've launched at the IES, which is called Turning the Tide, Systems Thinking for a Sustainable Ocean, in which we'll be hosting a series of collaborative events and activities throughout the year, aiming to bring together the marine and coastal science community around topical issues. For this project, we've got a dedicated mailing list, and through that, we'll be sharing updates on all the upcoming activities and calls for collaboration. And also, I'd just like to mention that this project has been led by our marine and coastal community at the IES. We've got a LinkedIn group for this community, and I would love to encourage everyone here today to join in that group and stay connected to our work in this area. I would like to now introduce today's webinar. So this will be on the impact of land use on marine environment. We're pleased to be joined by two speakers today. So we have Professor Mike Elliott, who is the Director of International Estuarine and Coastal Specialists Limited, and also the Emeritus Professor of Estuarine and Coastal Sciences at the University of Hull in the UK. Mike is a marine biologist with extensive experience across estuarine and marine ecology, policy, governance, and management. And we're also joined today by Professor Sian Davies-Vollum, who is the Deputy Dean in the Faculty of Arts, Science and Technology at the University of Northampton in the UK. Sian is a geoscientist with broad research experience, having worked on a variety of international, multidisciplinary and environment-focused projects. So, as always in our webinars, there will be a chance for questions at the end of the session. So please do submit these into the Q&A box at the bottom of your screen at any point during the presentation. I'll then be asking these on your behalf later on. All right, so thank you everybody for joining. I will now hand over to you, Mike.
Okay, thanks, Joe. Good afternoon, good morning, good evening, wherever you are. Having Zoom webinars has got many advantages, but the disadvantages that we can't see you in person, and it makes it more difficult to have a cup of tea with you afterwards there. As Joe mentioned, in kicking off this series for the IES, what I wanted to do is take you through some broad ideas about systems thinking and the way we link the science and management of estuaries, coasts and the seas to the land. As Joe mentioned, I'm director of a research company in the UK. Although we do work worldwide, got various projects in other continents at the moment, and I'm also an emeritus professor at the University of Hull. I used to be there as a full-time lecturer and teacher, but now I've moved on. Okay, so let's take you gently into this. That when we manage any environment, there's only really one big idea. That big idea is, how do we protect and maintain the natural stuff, and then we deliver the human stuff. What we talk about is the links between ecosystem services from which we then get societal benefits. And why do we need to do that? Well, all these points that you see at the bottom corner here, the bottom left corner, we've made a mess of environments, we've endangered some of the ecosystems, so we need to put that right. We have legal and administrative frameworks to improve things, and we aim for economic prosperity and as well as protecting the environment. And of course, there's the overriding aspects of climate change. So I'll try and touch on all these. Now, as many of you know, when we start any task, we need in our minds a conceptual model in some way. What is the underlying model of the way we're going to tackle a problem? And this is the underlying model we've been using now for probably, I guess, about 15 years, but it was built on another set of models, principally one called DIPSEA. This model here is where, if you think about it, we have drivers that govern what we do in the environment, our societal basic needs. Things like we need food, or we need shelter, or we need security, or we need employment, or we need aesthetic values and culture. Those drivers, in order to get those drivers, fulfill them, we carry out activities, we do something in the environment. We want food, we go fishing. When we do that, they lead to pressures, and a pressure is defined as a mechanism of change. So what are we changing? Well, firstly, we're changing the natural system, what we call the state change. And if we keep doing that, we lead to impacts on welfare, impacts on us. So we have a response. We do something to counter that. And this framework used to be called DIPSIA. We've altered it several times. It's now called Davies-Vollum. I started off with as a benthic seabed biologist working on worms. So we've used that in the title. So you've got that cycle, that Davies-Vollum cycle. So if you take any area that you're going to manage, and let's call it this boundary round here, that area has got a lot of these cycles in it. So number one might be, for example, wild fisheries. Number two might be aquaculture. Number three might be recreation. Number four might be navigation, and so on. So they've all got their own drivers, activities, pressures, state change, impacts on welfare, and responses using measures. Now, all I've done here is modify these to put the RMs together. And if we have all these responses together, we could call that an integrated management plan. And we start to talk about these as Davies-Vollum petals, because this looks like a bit like a flower. So they all occur within your management area, the area you're managing. And within those, we have what is called endogenic managed pressures. Now I'll come back to that in a minute. Outside that area are these other things that are occurring, exogenic unmanaged pressures, such as climate change, or even natural change. Now, if you think of that inner box as an estuary or a lagoon or a bit of coastline, then everything happens outside here is external. However, if that boundary is the catchment of your estuary and your river and your coastline, then all the rest of it is global changes. And we can then, thinking about this land use, the land-sea interactions aspect, you'll see for each part of this substance, we've got one of these Davies-Vollum flowers, but we can't just manage those in isolation. So this one refers to this estuary here, but we can't separate that estuary from the rivers, the lakes, everything that's happening in the catchment, and indeed everything that's happening out at sea, because that influences what's happening here. Yeah. I'll keep using the word catchment. I know in some countries they use the drainage basin, they call it the watershed, but I always tell my students that in geography, a watershed is a line and a catchment is an area. So let's call it a catchment there. This gives us a much larger model. You'll see I like diagrams, and so it gives us a larger model on which to base our analyses. Now, just very quickly, we have these drivers. We need activities in order to fulfill the drivers. Those activities in economic jargon are what are called putting in complementary capital and assets. And if we put in the capital, we get the socioeconomic and cultural goods and benefits, and they fulfill the drivers. But, and there's always a but, the activities lead to problems. They lead to sets of pressures. This part at the top here, oops, sorry, this part at the top, they lead to pressures, which is change and degradation of the natural state and change and degradation of the human state in the system. And if we keep putting in those pressures, we will affect this underlying central spine here that goes from the ecology through ecosystem structure and biodiversity, through ecosystem functioning, to ecosystem services, to societal goods and benefits. And in a lot of papers, you'll see that this change stops at ecosystem services, but for a while now, we've been splitting ecosystem services from societal goods and benefits. You have to put something into the system to get these benefits out. So when things are going wrong, we have to do something. We bring in management, and that's what these other boxes are about, on maintenance and restoration and carrying out management measures and governance and so on there. And I can come back to that. Well, when we start looking at land-sea interactions, we may think this middle part, in this case, we might call this the estuary, but that we've got exactly the same system in the catchment, and we've got the same system in the marine area. So now you start seeing, as Joe mentioned, why we start moving towards systems analysis. And I want to talk about that. I probably don't need to tell you how many things are happening in the sea and in the estuaries along the coast, but this list of activities there you see, and you'll probably recognize most of those, they're leading to pressures, and you see the pressures there, which are the mechanisms of change. So those are things that happen within an area. Coming from outside an area, however, are all these other things, what we call exogenic unmanaged pressures, things that are not, the consequences are occurring inside an area, but the causes aren't. And this puts it in simpler terms. As you see on this right side, these are the endogenic managed pressures, things that happen within an area, but where the causes and consequences are managed within the management area. And you recognize these things. Coming from outside the area are all these other things, the exogenic unmanaged pressures, where the causes need to be managed globally, but actually the consequences are managed locally. So things like sea level rise, when we're managing a particular small area, we're not managing the causes of sea level rise, but we have to manage the consequences of them. So the biggest problem with this is in defining the management area. And if we're looking at land-sea interactions, we have to include the catchment. And then you have to decide, is the catchment within your management area, and therefore everything is endogenic, or is the catchment outside your management area, say you're managing the coast, and it's there exogenic there. Sorry, the first one's endogenic there. We then say, where are the problems coming from? And now you'll start seeing how many of the problems are coming from the land and how many are coming from the sea. And a while ago, we started trying to look at what's called a hazard and risk typology, where a hazard is something occurs, and it might occur by natural or human actions, and it becomes a risk when it affects something that we value. So you see these are a set of, many cases, natural events. Many of these are naturally occurring, like storminess and earthquakes and subsidence. So they all occur naturally, but if they affect something we value, that hazard becomes a risk. And then there's that finishing the list, and you see here a whole set of anthropogenic hazards, like microbes or non-indigenous species or putting infrastructure in. So they're human caused, and then they're a hazard, and then they become a risk because they affect something that we value, and you'll recognize these. We published this a couple of times, and the last time we expanded it was to include geopolitical hazards. And I'm just starting some work looking at the Black Sea and the effect of the Russia-Ukraine war on the Black Sea there. Let's summarize that for the coast. And a little while we decided that coastlines are subject to what we call the triple whammy. A whammy is like a thump, as you see from those boxing gloves there. And the triple whammy, and this was after looking at coasts worldwide, we realized all of those coasts are affected by increased industrialization and urbanization. They all suffer from the increased use of resources, whether they are physical resources like space is a resource or energy or water, or biological resources like fish and shellfish. So we've got an increased use of these. And then the other one is a decreased resistance and resilience to climate change, these wider pressures. So we came to the conclusion all of these coasts are subject to this. And now you start seeing where the land is influencing these. But in addition to the land, we've also got many activities in the sea. And again, these activities are governed by what we're doing on the land, which is why we talk about the urbanization of the sea and industrialization of the sea. This is just a map of a small area, a part of the UK between England, Scotland, Wales and Northern Ireland. And you see what's happening there. So this started us thinking about the industrialization of these areas and these urbanization and the way we use the marine area. We use the marine area because of all the things that we want. And this is a stylized map of an area. It happens to be across two countries. There's one at this side, a dividing line, and one at that. And you see within those, there are many things happening. The discharges that come out from the catchment and give us this estuarine plume. There is the ports, the land-based discharges, the aquaculture on the land and attached to the land, offshore wind farms, and we need to get the cables ashore, bathing beaches, oil rigs, you name it. So we started thinking about the size of the problem, and you can do this for the land activities as well as the sea. We started thinking about these in terms of a footprint of the activity. Where does an activity take place? A footprint of the pressures that it creates, a footprint of the effects on both the human and natural features, and then the management response. And I'll try and quickly talk about all of those there. So when we think about these, the activity is usually quite small. The pressures gets bigger. The effects get even bigger because we're dealing with a dynamic system, and then we need management. And as I say, I'll come back to that. So we can think about the environment as having a type of environmental quality. And of course, if there's no activities there, then it's quite a high environmental quality. If we then have a set of existing activities, and these may be on the coast or they may be in the catchment, but there's a set of activities, and they're going to reduce this quality. What then happens is we put in mitigation measures and we get some quality back. Someone else comes along and wants to do something and we lose a bit more quality. We put in mitigation and get some back. Someone wants to do aquaculture. We put that in, we lose more quality, we mitigate it and get it back. And then tourism comes up and so on. And eventually this keeps happening until we get down to a state that we don't really want to happen. And by that stage, we work on the basis we have used up the assimilative capacity of the environment to cope with all of these areas, all of these activities. So we need to do something about it there. Right. In order to manage these activities, the land, the coast, the sea, we need to, well, in business, I know whether you're running the environment or a supermarket, the adage is you can't manage unless you can measure it. So we've got lots of indicators of all these changes in the system. And we need the indicators either to tell us what management is needed or to tell us, does the management work? So as you see on here, there's lots of indicators there. So the next point in all this is when we look at the problems that go from the land into the sea and the solutions, in essence, what we're doing is risk assessment and risk management, which is exactly the same if you were running a company, you would be carrying out risk assessment and risk management. You know, how to get your company or the environment do what you want it to and do it sustainably. So for a while now, we've been using a technique which is borrowed from industry. Industry have been using this technique for a long time to look at these problems. And this is called a bow tie analysis. And it's a bow tie analysis because it's got a central problem. And this problem could be know, how to minimize or the effects of high discharges from the land, or the effects of tourism, or the loss of a species or habitat. So we need to know, what are the causes of that, these blue boxes? Can we put in prevention between the blue boxes and the main problem? If we can't put in prevention, then eventually we're going to get consequences, you know, consequences of a loss of species, or a loss of habitat, or the adverse effects of tourism or whatever. So we put in mitigation. And you see now how it's a bow tie. It's got a central knot. We might have lots of causes and lots of consequences. And we've used this technique. I was going to give you more examples, but we'll run out of time. We've used this analysis in sitting down with stakeholders and working out what the problems are and what the solutions are. Sort of, where are the problems coming from? Do they give us opportunities, and so on? This wall of sticky notes was from a workshop that I was leading in Canada a little while ago, which was looking at the effects of all the activities on marine mammals as they pass through the area there. So now let's quickly talk about the solutions to these problems. So we've said where the problems are coming from. We've said what sorts of problems we've got. Now let's talk about solutions. And a while ago, we started talking about tenets of environmental management. A tenet is a sort of a soft law. And eventually we decided there was 10 of these. There's various iterations, and we published papers with 6 tenets and 7 tenets and 10 tenets, but there are now 10 of these. And you'll see that the solutions we've got for environmental management cover these things. Firstly, the solutions have to be, what does society desire, or what does society tolerate? You know, it might not desire to put its sewage into the sea, but it tolerates it. And usually because it knows it's a cheap way of getting rid of waste. We need our actions to be ecologically sustainable. We want to protect the natural features, but we know that managing the environment costs money. So are our actions economically viable? Are they technologically feasible? That is, do we have the technology in order to control the environment? Can we build the sewage treatment works, or can we put in changes to fishing gear or whatever? What about the laws? Do we have the laws to do everything? And do we have the administrative bodies to carry out those laws? And then what is it the politicians want? You know, in theory, they're following what we want, but sometimes you think it's the opposite. Especially in a country, we're going through the stupidity of Brexit at the moment, and we're bedeviled by a set of half-wit politicians. But I guess most countries have got half-wit politicians. And then what about the culture and the ethics of what we do? And then can we communicate these? So we've been doing this a lot. And what I want to do is just explain a couple of those in a bit more detail. By now, you'll be recognizing that when we try and manage systems, we are aiming to try and protect the natural capital, deliver ecosystem services, and give us benefits. And this is just a very quick example of that. We want to know, does the natural system function okay? What is the stock and the structure and the function of the natural system? If the waters are functioning okay, we get ecosystem services. Now, if we've got the right waves and tides and catchment inputs and so on, we'll get fish. We then put in our human capital, we build fishing vessels, and we learn how to catch these and so on. And we can turn those ecosystem services into our benefits, like fish and chips in this case. And the same for ecotourism along the bottom there. And so these are the models that we're using at the moment, and you can use these under any environment, of the way the natural system is running, these first 2 blocks, the ecosystem services that are being provided, and then eventually, after we put in complementary assets, we do something, we get societal benefits. And so now what we're doing is we can value these in various terms. We can ecologically value them, economically value them, and value them in socio-cultural terms. I'll make sure this presentation is available so it can be passed around later, so you don't have to remember all of this stuff. So the next part, very quickly, because I think we'll run out of time, is how we're managing all of these aspects. We have lots of ways of managing these things by the laws and the monitoring schemes and the programs of measures and so on. We have lots of those. All of our countries, and unfortunately I don't know where you're from, but I guess it probably is worldwide, all of our countries have signed up to a set of internationally recognized policies and principles. And I think you'll see from Sian's presentation, the way these are not only related to the global north, but especially to the global south as well. So we have the governance. And we manage according to all these areas. We manage the catchments, we manage the estuaries, we manage the coasts, we manage the sea. And we have a lot of management bodies that are involved in that management. So the systems analysis is now involved in bringing all of these different bodies together. And the governance horrendogram is quite complex. This shows the governance, the various legal laws and instruments going from the global, you'll recognize some of these names in the middle, out to the local. And then that's vertical integration. Horizontal integration is making sure we can manage all of the things. So some of these on fisheries and flooding and marine quality and catchment quality, shipping, environmental regulations, merchant shippings, power generation, and so on. So we need to get all of those in place. And very quickly, in a European context, and Sian will talk about southern aspects, in a European context, we've got, on that last horrendogram, there's lots of European laws mentioned, and this just shows where some of those are. The fact that some of them are on the catchment, like managing fertilizers and nitrates on land, and then some of these on the sea. And just very quickly, a couple of those of note are two of those bits of large European legislation, the Water Framework Directive, which is to try and protect the catchments and all the way down the estuaries to the coast, the Water Framework Directive, and try and make sure it's got good quality. And then two main marine ones, which is the Marine Strategy Framework Directive and the Maritime Spatial Planning Directive. And I haven't got time to go into these, but I can send you more information if you need them. But what this shows is we've now got the integrated management between the catchments and the coasts and estuaries and the seas. Where do those that integrated management comes in? It's the fourth of the types of footprint I mentioned, and this is the management response footprint. And this is just to show that those management responses go from very local level technical measures, say for an individual activity, which might only covers tens to thousands of square meters, all the way up to global areas. And then the corollary of that, the fact that we've got thousands and thousands of technical measures for every activity that we've got. So anyone who wants to carry out an activity in the rivers, the estuaries, the coasts and the seas needs to get permission to do it. That's why we've got thousands of these, going through marine plans, national policies, and up to global treaties and that then. And then bringing this all together, we end up with a systems analysis that says, let's start with the priorities and visions and issues of an area. What do we want an area to be like? B is getting the data and doing something with it. And then C is using the information in governance and management. So all of this has been published, even the more detailed systems analysis approach that we've got, where, as you'll see very quickly in here, where are the priorities, what are the repercussions of what we're doing, what are the issues in our areas, and then moving through how do we get the data, both the ecological and the socio-ecological and socio-economic data to look at these problems. And then how do we solve the problems using legislation and administration and so on. Okay, wrapping this up. All of our countries now have signed up to global agreements like SDG, the Sustainable Development Goals, and the C comes under number 14, but actually the coasts and estuaries and catchment come under all of these. And then I just very quickly want to talk about, just to show the way the science is going. At the moment, we've just started a very large number of European projects, and IX, the company I direct, we're in 4 of these. One is looking at good environmental status and cumulative pressures. One is on one called Marbethes, which is on valuing biodiversity. One is on the way we plan for these sea areas and so on, called Marine Plan. And one is on the last thing I touched on just then, which is socio-ecological systems and devising the socio-ecological systems. And there's a lot more of these, and I can give you more data if you want on these. So finishing off, there's a few main messages. Starting off with the objectives, knowing the management is based in good science, emphasizing the connectivity across all these things, and the connectivity includes the catchment out through the estuaries, the coast, getting good data, good underpinning concepts and so on, and harmonizing governance, and ensuring on top of all that we can cope with these local as well as global pressures. So that was a very quick whiz through, and it's probably longer. My apologies to Sian if I've stolen some of her time, but hopefully it set the scene, and we can come back to any other questions later. So I'll stop sharing there and hand you over to Sian.
Thanks, Mike. So what I'd like to do is to, and can everybody see my screen? Are we good? Okay. What I'd like to do is to take you to West Africa and give you some on the ground perspectives of this. So I wanted to give some examples from the Global South, because Global South has many rapidly growing coastal settlements. Urban areas are sites of in-migration. They're some of the most densely populated areas on the planet. Coastal rural areas provide some of the poorest communities on Earth with food security and income. The activities of these coastal populations are impacting the coastal and marine environments. Those activities have complex and interconnected effects on the adjoining marine areas, and it's that wicked problem of the land-sea nexus that I think you'll become aware of through what Mike was saying to us. And as Mike said, this requires a systems approach to address mapping problems, to understand the interconnectedness, their feedbacks, and their causalities. So I'm going to focus on West Africa here, and with my slides. So why West Africa? Well, it's part of the GCLME, the Guinea Current Large Marine Ecosystem. It's very, it has an area, it's an area of major coastal upwelling. It's really important for productivity and biodiversity. If we look at its coastline, it's also a focus of growing coastal urban areas and populations. So very interesting case study to look at that. That coming together and that influence of coastal land use change on marine environments. So the areas that I've indicated with red circles here are major areas of urban coastal growth. So Abidjan in Côte d'Ivoire, coastal population of 8 million, that's about a third of its population. In Ghana, Accra, the capital, has an estimated population of over 4 million, and 2/3 of the population live in the coastal areas. Lomé in Togo, nearly 2 million there. Cotonou in Benin, 1 million. It's Lagos trumps them all, and it's got a coastal population of around 16 million people, and it's, I think, second fastest growing urban area in Africa. And all of those activities at the coast are impacting on the nearshore and marine environments. I don't want to leave out the urban, the rural coastal areas as well. Fishing communities are still really important in these areas and have a very strong presence. And they also have an impact on the marine environment and vice versa. So what I'm starting with is a sort of systems diagram here. So I wanted to outline some of the key drivers that are causing those land use changes and having impacts on the marine environments, and then some of those resultant problems. I am going to be a bit of a naysayer, I'm afraid, and talk about some of the problems and not necessarily the solutions. That's a different talk. So rapid growth of coastal settlements, really key. Much of that growth is unplanned, and it doesn't just include communities and settlements, but industrialization. This places increased pressure on resources and habitat loss. There's a lack of infrastructure then through these unplanned settlements, and then a lack of legislation that really works, that can be enacted. That's largely due to poor resources being able to enact that legislation. So that's around all aspects of waste, domestic waste, industrial waste, sanitation, and drainage. And then a lack of management and legislation for resource use, and how that's changing the land use at the coast, and then that's influencing marine environments around deforestation, sand extraction, and water quality. And then finally, changing practices in agriculture and how that's changing land use, and changing practices in fisheries. This is all underpinned by climate change that is impacting all of these aspects, whether that be to do with changes in water resources, changes in weather patterns that are influencing these problems, erosion and flooding. So what I'm going to do, I'm going to take each of these four drivers and drill down a little bit with some examples from the region, just to give you a sense of what this means in practice, what's going on at the coast that's influencing the marine environment. So rapid growth of coastal settlements. I've got a few examples here. So those unplanned settlements are really driven by migration to coastal urban areas, and that's mainly an economic migration that's driving people there. That's leading to big urban sprawl at the coastlines, and that sprawl, those large urban areas, are really lacking in infrastructure that will help us to manage waste, manage resources that then impact the marine environment. Industrialization of port cities. I've got a couple examples of Lagos here, I previously mentioned, and then habitat loss and fragmentation. So that stretch, that expansion of urban areas in the coastline is causing some of those key coastal habitats to act as a buffer between the marine and the marine environment and land activities to be lost. And the picture I have here from El Nino in Ghana is of a big hard engineering project that has decimated the dune area that was one of those key sort of transitional environments between the land and the sea. If we look at the next of those drivers, that lack of infrastructure and legislation for waste management, sanitation is a challenge in this area. There's a lack of toilets in informal and poorest settlements and communities, and poor sewerage infrastructure when there are toilets. So much of that sewage in these coastal areas is then discharged to sea. The image that I have here is a campaign in Ghana to stop open defecation. That's a problem in some of these poorer coastal communities. And similar campaigns have gone on in other countries. In 2020, the Nigerian government launched what they called an emergency response to the sanitation crisis to specifically address that. Poor waste management is largely due to a lack of resourcing and a lack of access to waste management for those unplanned and informal settlements. The picture that you see here from Accra is the Keta Lagoon. That's one of the most polluted urban bodies on Earth. The lagoon has a direct connection with the ocean here. And all you see on the beach there are plastics. Hard plastics are a huge problem in terms of waste management. That continued use of imperishable plastics, and then the lack of ways in which those are managed or recycled. And the picture below it shows one of the options that coastal communities are often driven to, and that's to try and burn those plastics, but then that creates other pollutant problems. So often the solutions aren't meeting the need. There's also a challenge with stormwater runoff, and that's influenced by climate change and changes to weather patterns. It's exacerbated by open drains in many areas, and there's just a couple of examples here. So that's just feeding any kind of waterborne pollutants and hard plastics down into the coastal areas and into the nearshore and marine areas. I mentioned in my systems diagrams industrial effluent, and I'm going to pick that up in a moment in one of my next driver slides. Okay, so the next driver that I had on my systems diagram was that lack of management and legislation for resource use, and how that's changing land use and then impacting marine areas. So there are three main aspects of this in West Africa. One around sand extraction, and that's probably quite specific to some areas in the global south, and that's the mining of sand on the beach for construction purposes, and that exacerbates erosion, impacts sediment transport and resuspension, causes water turbidity and loss of habitat. There's legislation in most countries against it, but it's very hard to enforce and to police. Another key aspect of resource management that's impacting the marine environment is the deforestation of mangroves. Mangroves are the key wetland vegetation in many areas of the global south. We certainly are in West Africa. They're harvested for cooking fuel, and that's caused a lot of their decimation. And that's due to so they've been overexploited and cleared. And the picture you see here from Winneba, the topmost one, is that a lagoon that should be populated with mangroves as per the picture below, but has been decimated due to harvesting for firewood. Mangroves are key. They provide a range of ecosystem services, shoreline protection and buffering, sediment trapping, dissipate wave energy, help to regulate water quality, and also really key to the marine environment. They provide fish habitats, particularly fish habitats that act as nurseries for fish. So really important. The other aspect of resource use that's influencing the marine environment is water. And I mentioned the effluents already related to sewerage and waste in terms of hard plastics. There's also challenges around the regulation of industrial effluents. Nigeria has some of the worst oil spillages and discharges in the globe. Toxic chemical discharges and heavy metals are often made into open drains and sewers in some of these large urban areas. And there's also direct discharge to the ocean. In this picture from Benin is phosphate pollution going directly into the ocean. So there are a number of pathways going into the marine environment. So a number of pathways for pollutants going into the marine environment. So then the last drivers I had were around fisheries and agriculture. So fisheries are mainly small-scale fisheries, and they've seen aspects of overfishing, which has caused decline in fisheries. That overfishing is due to a number of different things. Some of it is industrial scale fishing that has provided competition for these small-scale fisheries that often are the sort of the lifeblood of a community. They provide food, they provide income, and when that competition is reducing fish yields, then there are cases of practicing fishing outside of the main fishing seasons, and different approaches that are less sustainable. So that might be dragnet fishing, it might be light use during to attract fish, and all of these are causing problems and downturns in fish populations. And I've got a couple of pictures here. The one at the bottom is showing an example of dragnet fishing, which is a traditional fishing method and can be used sustainably, however, is seeing increasingly unsustainable use. The picture of the plastics is interesting because what we're also seeing is those hard plastics are actually being brought up in the fishing catch, and then they're left on the beach. So they're exacerbating that waste management problem and just making it worse. In terms of agriculture, I want to go back to what Mike said about the catchment. So land use changes and agricultural changes in the catchment, particularly the use of farms, particularly farms that are using chemical fertilizers, are then leading to polluted waterways. And I'm sure you're all familiar with the link between chemical fertilizers and algal blooms. So the chemical fertilizers are finding their way into nearshore environments. There's also biomass, clear land for new agricultural land, and that causes problems with soil erosion and sediment in watercourses that finds its way into coastal and nearshore environments. So that's a quick run around key drivers that are causing land use change and land use change that is impacting the marine environment. Before I kind of finish, I want to give a note on, sorry, I had to turn my slides there. The influence of climate change. 2019 World Bank report looking at West African coastal countries noted that they're some of the most climate vulnerable in the world. Climate change exacerbates and complicates the issues that I've spoken about here. There's erosion and land loss, and you can see two pictures of erosion here in very different types of coastal environments, one more rural and one more urban. Flooding is causing land loss. Flooding is also redistributing pollutants, redistributing sediments and polluted sediments. Changes to the rainy seasons are influencing habitats and also influencing fishing and agricultural practices, and in some ways are driving some of those unsustainable practices. So this compounds those challenges that I've mentioned. I did mention that I was going to be something of a naysayer here. I really wanted to talk about the challenges that are specifically impacting that region of West Africa and how land use at the coast and its changes, and particularly the urbanization and the industrialization, is driving changes in nearshore and marine environments. What is required then to address these, and Mike's talked a lot about this at the start of the seminar, is really needing that systems thinking. So approaches need to be multidisciplinary, so working from different aspects. They need to include people and the social situation, as well as the physical environment, urban environment, and the natural environment. They need to be multi-institutional, so they are bringing different stakeholders together. Very important when we're trying to address these issues, to include people that live and work at the coasts, and that's that last point of being participatory. I'm going to end there. I would like to say that much of this work was supported by a Global Challenges Research Fund grant to develop a network of coastal researchers in West Africa called the Resilient Lagoon Network. We have a website if you'd like to check out some of our work. And I want to acknowledge my colleagues in Ghana and Benin and Nigeria who've worked on this with me. And just to end on a bright note, these three aspects of multidisciplinarity, multi-institutional, participatory, are part of a framework that we are introducing in the region around sustainable governance of those coastal lagoons, of coastal areas in West Africa. So I tried to do that as quickly as possible, a quick whiz around. Hopefully you got the essence of of that, and what land use in West Africa, those changes to land use are meaning for the coastal and marine environments in the region.
Brilliant. Thank you so much, Sian and Mike, as well, for your really interesting talks. Okay, so we have gone a little bit over on time, but it'd still be great to get a few questions in from our audience today. So if anyone's got any more questions that they'd like to put into the Q&A, please do submit those. So I'll start with one. So I guess I can pose this to both of you. So do you think that legislative approaches or the economic market are more effective in controlling negative impacts of the Anthropocene on marine environments?
That's a really interesting question. I saw it in the chat. Oh, firstly, my apologies. I thought we'd got an hour, so my apologies to Sian and you as well. It's what we call a senior moment. Yeah, never too young to have a senior moment. I tend to go back to Bill Clinton or one of his advisors when asked what was the most important question, and he said it's the economy, stupid. And I've noticed that if you get people discussing the effects of the environment on the economy, they take notice. If we talk to them about the ecology, they don't take notice. But of course, you need that the carrot and stick, and the legislation usually follows. And it's quite interesting, and Sian will know this, that if she's dealing with industries, especially multidisciplinary industries, multinational industries, sorry, if you tell them there's a law to do something, they'll usually follow it. If you tell them it's a guideline, then they might discuss it with their shareholders. But if there's a law, so I think you need both. But very often we often make the case that the economics is good. Good economics, a good environment is also good for the economy, and we have to emphasize these.
Yeah, I would agree. I think you need both. The challenge in West Africa is where there is legislation, it's enforcing that legislation. And traditionally, a lot of that legislation has been very top down, and it's not really impacted the people that need the legislation at the coastline. Yeah. So there's been a shift that has seen a more sort of participatory bottom-up approach, which is addressing some of this. But that sort of the status quo has been top-down legislation that just hasn't had an impact on the ground. So that's the legislation part. I think increasingly there is an economic aspect to this, and not necessarily with large companies and organizations, but startups and ecopreneurs. I know a number of individuals in Ghana that have either looked at recycling or creating non-plastic equivalents to, food containers, or looking at how to create sustainable energy sources for cooking rather than using mangroves. So I think there's a big there's lots of opportunities there as well, and I think you need an approach that takes the legislation and the economics together. I don't think you can divide them.
And just following that from Joe, these horendograms I've shown for the legislation and for the administration, we've gone for a long time about this, but we've looked at lots of countries now, and most countries have probably got all the legislation they need. They've probably got all the administration they need. It's just, and Sian mentioned this just now, it's just that we're not very good at implementing this. I know it's the ability to get away from or to beat the legislation, I guess. But where we've looked, most countries have got as many laws as they need and as many administrative bodies as they need.
It just doesn't have impact on the ground, and a lot of it is to do with the lack of resources to enforce and police, and it's also that lack of understanding locally. But also when you have those unplanned settlements, that then say you have legislation around waste and waste management, and that just doesn't reach some of those informal settlements because there isn't the infrastructure there to enact the legislation, and that's a challenge.
Right, thank you so much. I think in terms of questions, that's probably about all we have time for today. But thank you so much to both of you for your contributions. So I would, like to just thank both Sian and Mike for joining and presenting about some of your work today. It's been really fascinating to hear and to get your perspectives, both from work in the Global South and the Global. So thank you very much. Just a reminder to everybody that's attended that this webinar has been recorded and we'll be making it available on the IES website and our YouTube channel in due course. If you are watching back on YouTube, then please do subscribe to our channel, like our video, and make sure you sign up to get notifications of our content. So thank you again to everyone for joining today. I hope you have found it beneficial and you've learned a lot from this session. If you're an IES member, then don't forget to record your attendance at this webinar as part of your CPD using the tool through logging into our website. And lastly, I just want to make another shout out to sign up to our mailing list for the Turning the Tide project if you haven't already done this. We'll soon be sharing details through that mailing list of our upcoming events. We're going to be running some on ocean literacy and coastal management, so please do sign up to make sure you're the first to hear about those. And with that, I'd like to just thank you once again, Sian and Mike, and thank you to everybody who's joined and listened in and contributed today.
Thank you. Thanks for inviting us.
Thanks a lot. And if anyone needs the information, you got my email name earlier, so that's good.
Yeah, please feel free to contact me also.
Yeah,